Comparing results from StandardScaler versus Normalizer in linear regression. I'm working through some examples of linear regression under different scenarios, comparing the results from using Normalizer and StandardScaler, and the results are puzzling. I'm using the Boston housing dataset, and prepping it this way. I'm currently trying to reason about the results I get from the following scenarios. Initializing linear regression with the parameter normalize equals true versus using Normalizer. Initializing linear regression with the parameter fit_intercept equals false, with and without standardization. Collectively, I find the results confusing. Here's how I'm setting everything up. Then, I created 3 separate data frames to compare the R_score, coefficient values, and predictions from each model. To create the data frame to compare coefficient values from each model, I did the following. Here's how I created the data frame to compare the R² values from each model. Lastly, here's the data frame that compares the predictions from each. Here are the resulting data frames. Coefficients, scores, predictions, I have 3 questions that I can't reconcile. Why is there absolutely no difference between the first 2 models? It appears that setting normalize equals false does nothing. I can understand having predictions and R² values that are the same, but my features have different numerical scales, so I'm not sure why normalizing would have no effect at all. This is doubly confusing when you consider that using StandardScaler changes the coefficients considerably. I don't understand why the model using Normalizer causes such radically different coefficient values from the others, especially when the model with linear regression normalize equals true makes no change at all. If you were to look at the documentation for each, it appears they're very similar if not identical. From the docs on sklern.linear_model.linear. Regression. Normalize, Boolean, optional, default false. This parameter is ignored when fit_intercept is set to false. If true, the regressor's x will be normalized before regression by subtracting the mean and dividing by the L2 norm. Meanwhile, the docs on sklern.preprocessing.normalizer states that it normalizes to the L2 norm by default. I don't see a difference between what these 2 options do, and I don't see why one would have such radical differences in coefficient values from the other. The results from the model using the StandardScaler are coherent to me, but I don't understand why the model using StandardScaler and setting set_intercept equals false performs so poorly. From the docs on the linear regression module. Fit_intercept, Boolean, optional, default true. Whether to calculate the intercept for this model. If set to false, no intercept will be used in calculations, for example data is expected to be already centered. The StandardScaler centers your data, so I don't understand why using it with fit_intercept equals false produces incoherent results.
The reason for no difference in coefficients between the first two models is that StandardScaler denormalized the coefficients behind the scenes after calculating the co-Fs from normalized input data. Reference. This denormalization has been done because for test data, we can directly apply the co-Fs and get the prediction without normalizing the test data. Hence, setting normalize equals true do have impact on coefficients, but they don't affect the best fit line anyway. Normalizer does the normalization with respect to each sample, meaning row-wise. You see the reference code here. From documentation. Normalize samples individually to unit norm. Whereas normalize equals true does the normalization with respect to each column/feature. Reference. Example to understand the impact of normalization at different dimension of the data. Let us take two dimensions x1 and x2 and y be the target variable. Target variable value is color-coded in the figure. You could see that best fit line for data in Fig 1, 2 and 4 would be the same, signifies that the R2_ score will not change due to column/feature normalization or standardizing data. Just that, it ends up with different co-Fs values. Note, best fit line for Fig 3 would be different. When you set the fit_intercept equals false, bias term is subtracted from the prediction, meaning the intercept is set to 0, which otherwise would have been mean of target variable. The prediction with intercept as 0 would be expected to perform bad for problems where target variables are not scaled, mean equals 0. You can see a difference of 22.532 in every row, which signifies the impact of the output.
Answer to Q1. I am assuming that what you mean with the first two models is Reg 1 and Reg 2. Let us know if that is not the case. A linear regression has the same predictive power if you normalize the data or not. Therefore, using normalize equals true has no impact on the predictions. One way to understand this is to see that normalization, column-wise, is a linear operation on each of the columns, xa/b, and linear transformations of the data on a linear regression does not affect coefficient estimation, only change their values. Notice that this statement is not true for lasso/ridge/elastic net. So, why aren't the coefficients different? Well, normalize equals true also takes into account that what the user normally wants is the coefficients on the original features, not the normalized features. As such, it adjusts the coefficients. One way to check that this makes sense is to use a simpler example. Which confirms that both methods correctly capture the real signal between x1, x2, and y, namely, the 2 and 1 respectively. Answer to Q2. Normalizer is not what you would expect. It normalizes each row row-wise. So, the results will change dramatically, and likely destroy relationship between features and the target that you want to avoid except for specific cases, for example TF-IDF. To see how, assume the example above, but consider a different feature, x3, that is not related with y. Using normalizer causes x1 to be modified by the value of x3, decreasing the strength of its relationship with y. Discrepancy of coefficients between models, 1, 2, and 4, 5. The discrepancy between the coefficients is that when you standardize before fitting, the coefficients will be with respect to the standardized features, the same coefficients I referred in the first part of the answer. They can be mapped to the original parameters using reg4.coef_scalar.scale_. This is because, mathematically, setting z equals x mu/sigma, the model reg4 is solving y equals a1z1 plus a2z2 plus a0. We can recover the relationship between y and x through simple algebra. Y equals a1 x1 mu1/sigma1 plus a2 x2 mu2/sigma2 plus a0, which can be simplified to y equals a1/sigma1 x1 plus a2/sigma2 x2 plus a0 a1 mu1/sigma1 a2 mu2/sigma2. Reg4.coef_scalar.scale_ represents a1/sigma1 a2/sigma2 in the above notation, which is exactly what normalize equals true does to guarantee that the coefficients are the same. Discrepancy of score of model 5. Standardized features are zero mean, but the target variable is not necessarily. Therefore, not fitting the intercept causes the model to disregard the mean of the target. In the example that I have been using, the 3n, y equals 3 plus ... is not fitted, which naturally decreases the predictive power of the model. Smile.
The last question, 3, about the incoherent results with fit_intercept equals 0 and standardized data has not been answered fully. The op is likely expecting StandardScaler to standardize x and y, which would make the intercept necessarily 0, proof 1/3 of the way down. However, StandardScaler ignores y. See the API. Transformed target regressor offers a solution. This approach is also useful for nonlinear transformations of the dependent variable such as the log transformation of y, but consider this. Here's an example that resolves ops issue number 3. Which returns
If you want to see more, please consider subscribing.